We all know that in the world today, there's a lot of upheaval in the world and a lot of change happening. So there's not as many outlets or tools to be able to make those voices accessible. And so Adam and his team have put together a project which will try to address that and give a voice to the voiceless by way of peer-to-peer networking. And without further ado, I'll let Adam take it away.
Thanks so much, Jason. Yeah, so as Jason said, I'm going to talk to you guys about Lantern. Lantern's a tool for bypassing censors in countries that censor the internet. And it's funded through a series of grants primarily from the State Department. So it's total funding for Lantern has been about $5 million over the course of the last 3 years. And I'm really excited to be here at Google, first of all, just because the sort of the engineering talent on this campus is so amazing. And I'm going to talk a little bit about our organization and how we approach things. And I think that relates a lot to sort of the engineering talent that we see here at Google. So we're a nonprofit. We're called Brave New Software. And the Brave New Software's mission is to use software to tackle tough global problems. So the first problem we're trying to tackle is this issue of censorship. And to me, there's this really sort of a scarcity of really focused engineering effort sort of directly on problems like this. So I think Google itself clearly has this sort of immense, in some sense, philanthropic effect. You can do things with Google like detect flu outbreaks before the CDC is able to detect flu outbreaks. So just by virtue of making the world's information so much more accessible, Google itself sort of serves this incredible purpose. So whether it's climate change or censorship or poverty, I think sort of as engineers and with the capabilities that we have some obligation to sort of try to put forth effort to really focus on some of those problems. And that's really what we're doing at Brave New Software. So when I think about Lantern, to me it really starts when I was really young. So this is a picture of me when I was 3 or 4, and I grew up in a family of people who are a family of parents who were really focused on the green building movement and on using architecture to create social change, really. So at that point, the green building movement wasn't even really a movement. It was just sort of a couple of people with ideas. But because of that upbringing, I sort of came into this world with that type of thinking and that being around sort of very dedicated people as an everyday part of my life. So I think that really impacted sort of the way I approach the world and the way we approach software and problems at Lantern and at Brave New Software. So this is a shot of me. I think I sort of consider this the first version of Lantern in some way. So basically, my parents were constantly inventing things, and I early on sort of wanted to be a part of the action. So I somehow thought it would be a good idea to take like a toilet paper roll, the sort of inner cardboard tube from a toilet paper roll, and pair it with a burnout light bulb. And to me, this was a flashlight or a lantern of sorts. But if you look more closely, it's really, really kind of sad and just pathetic. It's just colossal failure on all levels and was completely non-functional. But this idea of just sort of participating and building things to make the world a better place was really part of my thinking from very early on. So fast forward, 18 years or so, I was one of the sort of core engineers on LimeWire, so did a lot of the raw engineering work on LimeWire. And that experience really reinforced this idea that small teams of people can create a big impact and can impact change. So at LimeWire, we were anywhere from about 5 people to 12 people, so an incredibly small group. And between us and the team over at BitTorrent with Bram Cohen and the team at eDonkey with Jed McCaleb came to account for, as I think everyone in this room knows, about 40% of all internet traffic in a very short period of time. This was a small group of people who were just massively changing the internet as we know it. And the other aspect of my experience at LimeWire was that it just had this component of being massively sort of decentralized. So it was much more decentralized than other peer-to-peer networks out there. And that was interesting from an engineering perspective to some extent in terms of not having a single point of failure, But to me, the more interesting part about that was really not having a single point of control. So how do we build networks that sort of more closely reflect the decentralized nature of the internet itself? So to me, that aspect of peer-to-peer was really interesting and got me thinking, even in those early years, about how you might be able to use those architectures to get around censors. So there was a piece of software called Triangle Boy around the year 2000 that used peer-to-peer to get around censors, and it was more of an experiment at that time, but that made me first to start to think about how you might use this stuff to bypass censors. So I think it was 2009, oh, sorry, actually, I'm going to talk a little bit about just the problem of censorship. So to me, living in this country, it's very difficult to understand what it's like to live with censorship. So without being able to access all the sites we want to access every day, I think it's just a challenge to really understand what it's like. So this is just me proxying my traffic through a server in Iran and trying to go to Twitter and to YouTube, and you see this blocking page come up that just lists other sites that the government recommends that you might want to go to instead of Twitter or YouTube. And if you do this for a very short period of time, it's amazing just how sort of debilitating it is to your everyday experience. So you get an email from someone with a link and you can't watch it. And so for me, if I do this for about even as little as half an hour, almost instantly, it's just like incredibly frustrating, and I just can't take it anymore. I have to like turn off the proxy to go back to sort of life as we know it. So literally, when I first started work on Lantern, I was just in the shower one day, and I was like, hey, I think I'm going to actually just start coding today. So the first component I started coding on was LittleProxy, which is just an HTTP proxy. And for me, it's oftentimes hard to really feel like I fully understand something until I code it. So with even an HTTP proxy, it's relatively straightforward in a lot of ways and on a conceptual level. But I felt like I just really wanted to code it. First, I didn't feel like there were any really good proxies out there, and I felt like I wanted to just really sort of immerse myself in it. So even things like HTTP Connect, like that's a kind of an interesting HTTP method, and it means you can tunnel anything through HTTP Connect, right? And so conceptually, you think, oh, okay, that makes sense. But when you think about it, it's actually incredibly powerful. Like you can tunnel absolutely anything through HTTP Connect, right? You can speak any protocol you want to speak. Which is kind of a big deal, and that's something we take advantage of in different ways in Lantern. So the other reason I bring this up is just from a sort of a modularity software engineering perspective. So LittleProxy is a totally separate project, just a straight HTTP proxy, and at this point it's used all over the world. So it's used at Red Hat, it's used at Electronic Arts, it's used at New Relic, and at small businesses all across like Eastern Europe in particular for some reason. But none of the people using it have any idea that it's also used within Lantern, right? So they're actually patching it and improving it all the time for their own purposes, but they have no idea that at the same time they're testing and improving Lantern itself. So to me, that's how good sort of open source and modularity works, is if you build something that's useful to people more generally and also useful to you. Oh, sorry, I think there was some animation there. So this is just a shot of someone, not a real person, but at home running Lantern. And the way Lantern works is users in uncensored regions can download and install it on their computers. And because you at home have access to the open internet, people can proxy through you and themselves get access. So it uses this peer-to-peer model that does a couple of things. On one level, it really ramps up the number of access points. So we try to make it very easy to run a new access point, and it's literally you just download and install it on your machine and just run it. So just through sheer numbers, Lantern tries to be much more blocking resistant than sort of existing solutions out there. They're just making it much easier to deploy new instances. So this is a shot of a much sort of earlier version of the Lantern user interface. But one thing we try to do in the user interface itself is just really give people this sense of connection to people around the world. So we're trying to build this just like citizen-run piece of software that allows people around the world, no matter where they're from, to directly connect. So this is showing in real time your connections around the world. And this is mock data at this point. I'll show you some live data later on. but this is an example of a user connecting from Iran. So one aspect of, I want to dive into some of the more detailed engineering things that we do. So blocking resistance is really a core part of Lantern and differentiates it. Some of the ways we do blocking resistance differentiates it from certainly Tor and from other tools out there. So we use this algorithm called Kaleidoscope to distribute addresses of proxies. So one big challenge out there is how do you distribute the addresses of proxies/access points in such a way that people on the network can discover them, but sensors cannot, right? So Kaleidoscope uses a trust network to do that, and basically what Kaleidoscope calls advertisements for proxies sort of trickle through the network first along a random walk, and basically from that point after, it just uses the same random walk. So it initially chooses a path and then always uses that path. And basically the idea is that if a sensor joins the network, they're not going to learn about all of the proxies that are already there, right? They can't, a new actor on the network can't learn about all the existing proxies. They might learn about new proxies, but they won't learn about existing proxies. So that's one way that Lantern stays unblocked. And yeah, so and basically, so the sort of key component of that is, again, this goes back to this peer-to-peer element. So this trust network component is useless unless you're able to connect peers directly, right? Like if I trust an individual other user on the network, if that's just some server out there, it sort of breaks this trust network model because that's not associated with an individual, at least in the sort of normal conception of it. So the way we do peer-to-peer in Lantern is using WebRTC, and we're releasing a new library called Natty that basically wraps up the WebRTC implementation in Chrome and just releases it as a separate library that anyone can use as a standalone entity. So, and I imagine most people here are familiar with WebRTC, but basically, uses UDP to traverse NATs directly between browsers. We're using it not within the browser, but within Lantern itself to create that peer-to-peer connectivity. So doing that over UDP has some interesting properties. So it just so happens that particularly over these long-distance links that Lantern tends to deal with between, say, China and here in Mountain View, TCP really doesn't handle that well. So it sees this high latency connection and sees this high packet loss and mistakes it for congestion, essentially. So it sort of settles on a sub-optimized window size that really slows down the connection. So by implementing custom protocols over UDP, we're able to really speed up those high latency connections between uncensored regions and censored regions. And it sort of just so happens that the best way to traverse NATs and firewalls is using UDP. So it's a sort of a handy marriage there. So I want to dive into a little bit sort of how we've released this stuff over time around the world. So this is just a shot of satellite dishes in Tehran. So in Iran, it's illegal to own a satellite dish. But if you look at the skyline of Tehran, you see satellite dishes everywhere. So Lantern, in a lot of ways, is similar to that in the sense that it's very visible. These satellite dishes are very visible on these rooftops. And Lantern, or really any tool of this type, like Tor or anything else, is very visible on the network. Like if you're looking at all the network packets passing through the entire country, you can see that these connections are unique, or these users are using the network in a unique way. So Lantern is certainly visible on the network in that same sense, and it's focused on access in the same sense that these satellite dishes are focused on access. So we don't really get into anonymity, certainly in the way that Tor does, but our primary focus is just staying unblocked and providing access. So in terms of these satellite dishes, this was one of the sort of a milestone moment in Lantern's history last December, or I guess November actually, when we went on a satellite television station called Monoto 1. So Monoto is the largest TV station in Iran, or largest satellite TV station in Iran, and because of that, the largest station period. And this is just the Lantern piece on Monoto. And basically, in order to facilitate this broadcast, they asked us, hey, can you open up downloads to Lantern from the website as a part of this broadcast to allow so that we can announce this thing and have people actually be able to download it? Because prior to that, based on that kaleidoscope algorithm we were talking about, Lantern was invite only. So the only way to get access to the network was through your friends already having access and getting invited. So we did that, and to some extent we sort of broke our own rules when we did that. Basically what we allowed users when they came to our website to enter their email address, and we would just automatically invite them. And relatively quickly in Iran, certainly the day of this broadcast, a fair number of people started picking up on it, but within hours in China, social media in China really started to pick up on it. So we started getting far more downloads from China than from Iran within that first 12 hours. But the problem was that we were, again, sort of breaking our own rules in terms of blocking resistance. And basically, about 4 weeks later, there was an article in the South China Morning Post announcing Lantern, or describing this massive growth of Lantern in China. And then about a week after that, Lantern was blocked. So it seems like that article really focused the attention of the Great Firewall, people working on the Great Firewall, to get them to block Lantern. And at that point, because we had sort of intentionally broken our own rules, it wasn't so surprising. But at the same time, we wanted to be able to release Lantern just directly from the website through open downloads to allow anyone to access it. So we had this sort of problem. How do we release this openly so we can help more people while at the same time keeping it unblocked? So in that instance, it actually turned out that the way that they were blocking it was not through infiltration, but was rather through fingerprinting our traffic on the network. So we were actually able to fix that relatively quickly, so to look really exactly like Apache byte for byte. Prior to that, we didn't look like Apache byte for byte over the network, and changing that really fixed that problem. But in that window, it was the case that if you ran Lantern at home on your home network, literally your computer would be blocked from China within like an hour and a half. So no traffic would be able to flow to your machine from China within about an hour and a half. But we fixed that within about a week, but we still had this problem of how do you distribute Lantern more broadly while keeping it unblocked. So what paths forward are there, and what have we implemented? So basically, there's this thing called domain fronting that goes by a couple of different names, but really the promising strategies all revolve around this idea of collateral freedom. So this idea of sort of strength of numbers, this idea that the best way to stay unblocked is to somehow hide in other things that censors don't want to block. So you see that with things like Amazon AWS, right? Like a lot of Lantern and a couple of other tools for a long time were distributing all of their installers on S3. Because basically if you're accessing S3 over HTTPS, the only way to block that link is to block all of S3. And we thought that censors would never take that step, that especially the Chinese and the Iranians would never take that step. But about 2 months ago, they did. So China essentially blocked all of S3 while sort of opening access periodically to some data centers. But they blocked all of S3 for the most part, and crippled not only Lantern, but sort of untold sites on the internet. So in that case, they were sort of willing to accept the collateral damage associated with that blocking. But another sort of, I guess, more promising example of this collateral freedom thesis is this idea of domain fronting that I mentioned. So with domain fronting, basically you can trick websites or in websites/CDNs into routing things to places that they weren't intended to be routed. So I'm just going to show you a quick example of doing this over curl. So this is just going to be a curl call to Hacker News, to news.ycombinator.com. And basically all we're doing here is specifying a header in the host header specifying reddit.com, right? And you're going to see what happens here. And note that it's HTTPS, right? So we're making an SSL connection to Hacker News specifying a host header of reddit.com. So you see that in the result, and we're just grepping for the title in the HTML. So you can see in the result, it clearly returned Reddit, right? So that's kind of interesting, right? It returned a site that it was not specified in the original URL. So from the perspective of a censor watching this, they'll see this connection to news.ycombinator.com, this SSL connection, but then at that point, everything's encrypted, right? They don't see that HTTP host header passing through, and they don't see that eventually this is going to reddit.com. So on the one hand, that's kind of interesting in the sense that you can imagine instead of reddit.com, I think Reddit is actually unblocked surprisingly pretty much everywhere in the world, but you could imagine that being just some blocked site. So you could go directly to a blocked site, or you could imagine that being a connection to one of our servers, right? So this is a diagram of sort of what's happening under the hood. And so if that's going to not just another website, but one of our servers can go anywhere, right? So our proxies can send traffic wherever they want. So that's exactly what we do. And this is David Fifield, is a researcher over at Berkeley, who's been doing some great work in this area. So this what I just described is both implemented in Lantern and as a pluggable transport in Tor. So this is a diagram from David, who's a volunteer on the Tor project. But yeah, so this demonstrates going directly to, using that little trick to go to one of our servers instead of going to the destination website. And so the neat thing about this in terms of all this issue of like, how do we enable open downloads, is that all of a sudden, if the IP address of a Lantern server is blocked, it doesn't matter, right? Because all the censor sees is this SSL connection to this other site, right? And then we can send that traffic wherever we want. So in Lantern's case, we send that traffic not just to our servers. So Lantern is a hybrid system where we run some servers to make sure that people's quality of service is good. But we send it also to peers, right? So we're actually entering peers in our DNS round robin and using this domain fronting technique to get to those peers, right? So in that host header, we're specifying it's actually roundrobin.getiantum.org for who knows what reason, but that's not actually entered in DNS, but in this example is on Cloudflare's DNS. So we're in that host header sending you to our DNS round robin that is a mixture of peers in our servers. So that enabled us to re-release these open downloads while staying unblocked. That little trick. And one of the goals behind Lantern that I didn't really mention, and one of the goals with this peer-to-peer component is scalability. So we're really interested in the peer-to-peer aspect in terms of blocking resistance, but also in terms of scalability. If 500 million people in China all got on Lantern tomorrow, or all started using censorship circumvention tools tomorrow, we'd have a big problem. And you really could not, possibly Google could accommodate that type of traffic for proxying, that number of people. But sort of any normal entity with lesser means would not be able to do that on a financially scalable way. So this is a shot of when we enable this peer-to-peer traffic in our round robin of one of our servers, the load on one of our servers. So you see, as soon as we enabled peers, just the CPU just dropped to almost nothing, right? So with all of these peers running Lantern in the uncensored world, acting as these access points, all of a sudden we can build a system that is financially scalable in terms of solving this problem. So this is just a shot of me running Lantern at home. So once we started releasing this domain fronting technique, if you just run Lantern on your home machine, you'll start to see this traffic from all over the world coming through you. So this is live traffic, and this is when we first started to really push this out. So you actually you'll see a lot more traffic now if you run it. But this is to me sort of the exciting part, is you all of a sudden sort of feel this sense of connection with people around the world and are actually tangibly really solving this this problem of censorship and are actually giving people access in real time. So one night I just tend to run Lantern in what we call give mode on my machine overnight. And this one night there was some little glitch where like I went into dev mode in Chrome, and somehow I think there's basically some bug in the Lantern UI that made it show all of the connections throughout the entire night. So I just took a screenshot of that, and you can see that's my computer there in Los Angeles, and you can just see all of these people connecting through me throughout the night from all over the world. And in some cases, obviously, a lot of these connections are not from censored regions, and Lantern does that for a couple of reasons. So like, for example, when it first runs, we don't know where you are, so we have to geolocate you in some way. And to do that, oftentimes we have to tunnel that traffic, so we don't know if the geolocation servers themselves are blocked. So we'll tunnel that traffic through Lantern as well. But to me, this was a really sort of gratifying moment, because the combination of just being able to instantly help out through running Lantern on your home machine and really demonstrating the financial viability of this model with peers really taking the load off of those servers was just a super exciting time. So and I guess with Lantern down the road, as we kind of move forward, we're really just pushing it out much further, and really are still honing this domain fronting technique. So there's a lot of little quirks to how this works in terms of like you have to tunnel things through HTTP post requests and tunnel them back through GET requests. So it's still very much a work in progress, and we're definitely trying to grow the Lantern team and push it out much more broadly around the world. So we certainly could use all the help we can get. I know 20% time is maybe not what it once was at Google, but we could certainly use all the help we can get in terms of whether it's engineering help or even project management or product management help. So yeah, thanks so much for your time, everyone, and really appreciate it.
So what stops, say, the Chinese government from just running a whole bunch of fake Lantern servers and making the service unusable?
Yeah, that's a great question. So I think to me the key there is unusable. So from our perspective, if the Chinese government wants to run a bunch of servers that actually proxy access, that's fine. And if you think about it, they already see all the traffic coming in and out of the country. So they have infinite visibility into the network traffic. So it's not as if they're running a server, they necessarily have more visibility. But if they're so there's that aspect to it. But then there's this aspect of servers that don't work, right? So what Lantern does is it'll detect, does this server allow TCP connections? Does it actually return the site that I requested it return? And it'll take proxies out of rotation if they don't work.
But it might not be easy to detect a poorly behaving proxy. Like, what if they just slow everything down like a ton?
Yeah. So certainly that to some extent that's an arms race. Like a dedicated adversary doing those types of things would be challenging in terms of like things that are easy to detect are a proxy not accepting incoming connections. Or not, like we require that a proxy always accept incoming connections within 5 seconds. But things like it's really slowing things down, that's a bit harder to detect. And currently in Lantern, that would be a pretty effective attack. Down the road, we'll start to do things like just, even for performance reasons outside of attacks, track the performance of proxies in general, so we can rank them. So we want to give you fast service no matter what. So we'll always try to send you to a fast proxy. Right now, we don't really get into that, but that's definitely an interesting attack on the network for sure.
I wonder if accepting money from the State Department affects adoption.
That's a good question. Yeah, I mean, we don't really know. We don't really have a lot of visibility into that. I mean, I think it's this came up. We did a Ask Me Anything, an AMA on Reddit, and this question came up, and there's clearly sort of comparisons between the State Department and the NSA. And in responding to that question, I think that this response applies here too. I just was pointing out that the branch of the State Department that we work with is the Bureau of Democracy, Human Rights, and Labor, right? So their entire mission is to advocate for human rights and freedom of speech around the world. So if you actually like talk to these individuals and get to know these individuals, they're just literally these like public servants who are working for much less money than they would otherwise be making in like these terrible offices in DC. You know, so it's so really those individuals end up controlling this money, and they are very much like-minded and have a very similar mission to our own mission. So it very may well sort of hurt adoption, and we try to be as open about that as possible. But in terms of how much it actually affects adoption, that's unclear. I think for the most part, people in our experience, people in censored regions will use whatever works. So if something works, they don't, for the most part, care why it works. But I think it may be more of an issue for the uncensored regions than it is for censored regions, actually.
What kind of anonymity does Lantern provide?
Really, very, very little. So I mean, it's a one-hop proxy, so there is some degree of anonymity that one-hop proxies provide, but we basically just try not to even get into the anonymity game. So we work pretty closely with various people on the Tor team, and if you really need anonymity, we would really recommend that people just use Tor. From my perspective, I think that tackling sort of really usable tools that stay unblocked while also tackling anonymity is just super, super challenging. So we're really focused on just building a tool that stays unblocked and provides really usable access. And yeah, like if you're a political activist in Iran or China or something like that, we would really recommend that you use something like Tor, particularly if you're nervous about your things that you're doing online.
I'm asking that question because I come from such a country where once you're known, you can go to jail. And
yeah, right.
bad
So
things can happen to you.
yeah, so I mean, I think those issues are interesting. Like it's like, you know, I think to me, if you're a political activist in a region, you know, it's to some extent the same as being some political activist who's actually potentially doing illegal things in the U.S. Right? So things like running Tor or running Lantern, I think a lot of times just the visibility on the network, like the fact that you're running these tools, might be enough if you're an activist to give a regime an excuse to go knock on your door and pick you up. But I think in a lot of cases that just visibility on the network itself is almost as much of an issue as the anonymity. So because like if you think about it, if you're running Lantern in China and you're visiting some website, if that website is not in Iran, or in, sorry, did I say China? I can't remember. That's China. Yeah. If you're in China and visiting a website that's not in China, a censor is not going to be able to see that, right? So they're not going to de-anonymize you that way. So if you're visiting a website that's in China, they'll be able to de-anonymize you, but that's also an issue with programs like Tor. So the idea of anonymity is I think much more granular than we think of it as. There's anonymity in the face of a censor, and there's anonymity from a website. And I think those are very different in different scenarios.
You mentioned that the clients use a geolocation mechanism.
Yeah.
So that makes me wonder if in this binding to proxies and the random walks and so on, there's some kind of optimized routing you're trying to do.
Right now, we don't get into that too much, but we are seeing, especially with that domain fronting technique that we've been doing, that you're jumping through so many servers that the geography starts to become a bit of an issue. So with the peer-to-peer stuff, we don't do that, but we are starting to look at that more with. We may actually start to look at it with the peer-to-peer stuff itself to try to really locate proxies closer to Cloudflare data centers, essentially. Because with that domain fronting technique, at this point we're tunneling through these Cloudflare data centers. So that's really the geography that makes the most sense. Cloudflare uses Anycast, so in China that tends to be the Cloudflare data center in Korea. So really we want peers in Korea. But at this point, partially because of that trust network aspect, we can't optimize the peers too much. But certainly. So if you have a lot of peers, we would be able to potentially, but over time that's going to be a much bigger issue, I think, because they're staying unblocked and being somewhat usable, and then the sort of next step is speed, so making it as fast as possible.
But then the Chinese censor's proxy would win, right?
That's true. And again, so that's right. So but in that case, that's okay. So there's latency and then there's throughput, right? So if they're throttling the throughput, then that's an issue. If they're low latency, that's great. But so we have to detect those things independently. Yeah.
I guess I'm just trying to get at that. I wonder if there's a fundamental trade-off between performance optimization and the obscurity of proxies.
Certainly, if we sort of again broke some of our own rules in terms of the trust network and chose proxies that were faster, regardless whether or not they were trusted, that I think that would be true. But yeah, and there might be attacks there where, like, if you certainly we assume that sensors will penetrate the trust network. So if they are able to penetrate the trust network, then we would tend to preference closer peers. But again, I think a lot of that stuff comes down to Lantern just detecting how well these proxies are actually working and taking them out of rotation if they're doing anything at all sort of suboptimally. Yeah, but that line of attack is definitely an interesting one for sure.
Lantern has tremendous potential for good, but how do you prevent malevolent use, like systemic child pornography distribution using your services? Do you see necessary limits to this technology? Are there abuse reporting abilities?
There aren't abuse reporting abilities right now. I think that's an excellent question. The one thing I didn't mention about Lantern in terms of how it works by default is that it uses a whitelist. So it uses a whitelist of sites that it provides access to that we know are unblocked. So child porn sites are not on that list, for example, and primarily those sites are newspapers we all know and blogs that we know to be blocked in Iran and China. So I guess in my experience, just releasing consumer software, you can't overestimate the laziness of users. So like the defaults make a huge difference. So I actually think that whitelist is a significant factor in terms of mitigating against that. The other thing that we're looking at is implementing safety NS on the give mode side, so on the uncensored side. So allowing uncensored users to essentially act as censors. So to specify, okay, we only want to allow sites on the whitelist, for example. Because users in censored regions can customize the whitelist. They can add their own sites that they know to be blocked that maybe we don't know about. But we're strongly considering allowing uncensored world users to limit how much sort of customization they will allow through their computers. So that's another factor. I think beyond that, I would say to some extent, a criminal who would use use Lantern is a bad criminal. So like I think to some extent, a more sophisticated criminal would just use Tor. Because Lantern doesn't provide anonymity in those ways.
How big is the network? How many active monthly users?
Oh gosh, we actually haven't. We've done a horrible job of tracking active monthly. It's about 1,000 at any one time.
Proxies?
1,000 just users running. So it's about 50-50. Well, actually, it's changed a little bit more recently. I think it's maybe 60-40 censors to uncensored. So it's a little more uncensored, or a little more censored world users than uncensored at this point.
All right. Well, thank you, Adam. Really appreciate your coming in and presenting. What the Lantern project. If anybody's interested in getting in touch with Adam about potentially participating or taking part in it, we can exchange information after the tech talk.
Sounds good. Thanks so much, Jason.
Yeah.
Appreciate it. Thanks, guys.